Hello friends, this is Durga from ITversity, a one-stop shop to learn all the technologies. Hello friends, I hope you guys can see me. So let me share my screen. This is the first time I'm doing YouTube live, so if there are any issues, please excuse me. I will try to resolve those issues very soon. So I'm starting my screen. Sorry, it got disconnected. I'm back. Let me share my screen now. So the agenda of this session is to set up the development environment. It's kind of a workshop. And also I'm trying to experiment YouTube live. I'm doing this for the first time, so I just want to demonstrate how to set up the development environment on PC for develop big data based applications using Java MapReduce or Spark. So that being said, let me go to the page. So just today I have published a blog, and I will review that blog itself as part of this session. So this is the blog setup IDE for big data, Hadoop and Spark, and you can actually go to my website called itversity.com and click on blog, and this one will be the latest one. So as part of this, we will see the steps involved to set up IDE for developing big data applications using Java for MapReduce and Scala for Spark. So first we need to, so before getting into the details, let us understand how long it will take. So this will take anywhere between 3 to 5 hours to set up end to end. It involves developing a few gigabytes of software to set up virtual machine using Cloudera Quickstart or Hortonworks for those in US. For those in India, depending upon their speed, it might differ significantly, but in US, it will typically take anywhere between 3 to 5 hours to set up end-to-end stuff. I already have most of the stuff, so as part of the demonstration, I will only cover few of the areas instead of everything. Okay, so this will make you comfortable in developing Java MapReduce based applications or Scala based Spark applications. Okay, so to set up the environment before setting up the IDE, you have to set up the virtual machines, or you need to have a single node lab on cloud. So there are certain prerequisites which you need to have to set up the virtual machine. For example, to set up virtual machines, you need to have at least 16 GB laptop. If you have 16 GB laptop, you can download Cloudera Quickstart VM or Hortonworks Sandbox, and then use virtualization software such as VirtualBox and VMware, and then you can actually set up the virtual machine on your laptop. The virtual machine will look like this. So I'm opening up my virtual machine. I am using VMware software, which is called as VMware Fusion for Mac. Similar technology for Windows is called as VMware Workstation. On top of that, there is VirtualBox software also, which is absolutely free. But VMware costs money. So all those details are furnished as part of these blocks. So this blog is consolidation of multiple blogs or multiple topics, and I have provided links here. So from here, if you click on this link, it will take you to the steps where you have where it will facilitate you to set up Cloudera Quickstart VM. Okay, it includes the setup of the VM and also quick quick preview of the VM as well. Before getting into that, you have to install virtualization software, and as part of this URL, we see what are the available virtualization softwares, and on Windows, what are the tools you need to set up, and then the VirtualBox, and then VMware, and also I have covered the pricing differences between VMware and VirtualBox as part of this post. That being said, now I'm going to the main blog, which is to set up IDE for Big Data, Hadoop, and Spark. So first you need to set up virtual machine, and the virtual machine comes handy in several ways, but that doesn't mean that you need to have to set up IDE. Even with IDE, you can start developing the MapReduce programs, but you will not get the feel of executing in the big data environment. And also, if you don't have virtual machine, you will not have access to other big data ecosystem tools such as Hive, Pig, Scoop, etc. Everything you have to set up manually, which is quite cumbersome. For that reason, it's better to have virtualization software and then have the Cloudera Quick Start VM or Hortonworks Sandbox on it. If you don't have a good laptop, so to set up this VMs, you need to have a 16 GB laptop, i7 processor, quad core. If you don't have that configuration, then in most of the cases, you will not be even able to set up the environment. Even if you are able to set up, it will not be reliable. It will be crashing every now and then, and also it will throw some weird errors. For that reason, you need to have at least 16 GB RAM, i7 quad core laptop to set up the virtual machine. If you don't have the that kind of laptop, if you are ready to spend some money on cloud, you can actually provision an EC2 instance or a virtual machine from the cloud provider such as AWS, and then set up the single node lab in that. This step will take a few hours, at least 3 to 4 hours, because it's tedious. It's not as straightforward as setting up the virtual machine. And this blog post will cover step-by-step instructions to set up that one. Okay, so now once you have the Hadoop environment, we will see how to set up Eclipse with Maven. So for that, again, if you click on the link, you can go to the detail. So the one which I typically use or which I recommend is called as STS, which stands for Spring Tool Suite. Spring is a Java-based framework, and it is also it is owned by EMC, and they actually provide development tools for developing Spring-based applications. And this Spring Tool Suite or STS is built on top of Eclipse. So you can use this one. This comes handy with Maven plugin, so you don't have to set up Maven. Additionally, it comes with Maven. On top of that, if you already have Eclipse, if you don't want to use STS, you make sure you have Maven plugin. As long as you have Maven plugin, you are good to go. You don't need to download or set up anything. Okay, but if you are new to Java, I will highly recommend to go with STS, which is nothing but Eclipse plus Maven plus few other tools related to Spring, which we are not interested in. We are primarily interested in Eclipse and Maven, and Spring Tool Suite comes with that. And the download is pretty easy. So you can see here they have given the links for Windows, Mac, and Linux. I think you can actually click on the tools, and this is the download STS. Okay, on Windows it will show for Windows, on Mac it will show for Mac, but the binaries are same. When you actually, if I hover that, around here you can see the URL. Okay, and the URL says it's a tar.gz file, which means that it's a tarball, which is nothing but a package, and gz extension stands for compression. So if we click on this, it will download a file similar to this one. Okay, Spring Tool Suite 381 release E4.6 macOS X Cocoa-x86 _64.tar.gz. So this is the version which will work on macOS. Similar to if you go to the same page on Windows laptop, you will see 381 release for Windows, and when you click it, it will download it. So the application is smart enough to understand from what type of machine you are trying to access. If you don't see release for Windows, you have to click on see all versions, and then you have to choose the appropriate version from here. Okay, and from here you can actually download the 64-bit version of software. Most likely, if the laptop have more than 4 GB RAM, it should have 64-bit operating system on it, and you have to download the 64-bit STS. That being said, once you download, you will see file like this, and then you have to say tar, because we have to unpackage this tarball. X for extract, Z for unzip. So to extract tarball, we have to use X as the control argument, Z to unzip, and F to unzip all the files. And then we have to give the path of our tarball. And when you run this command, it will just take a moment, and it will create directory called stc-bundle by default. If you want to change it, you can change it, but the default directory will be sts-bundle. And then I have already done that, so I will not be running it again. And then you can go to the directory where it is unzipped. In my case, I have unzipped in my home directory, so I am in the home directory, and I can see stc-bundle here. We can expand it, and we can double click on STS, and it will come up like this. So I'm quitting it, and I am opening it again. Okay. Now it will open up a Spring Tool Suite, and here it will ask you for the workspace. You have to make sure that you create a proper directory, a proper working directory where you will be developing the projects. In this case, I want a different workspace for the Scala, and I want a different workspace for MapReduce. Okay, I have already created that workspace. So Big Data Spark Scala is for the Spark-based applications, and for MapReduce, let me create a new one here. I will create Big Data-MR, and then click on OK. So this is after downloading the STS, and after unzip and after installing STS by using tar-xdf command, you will see this one. And then here you can check for you can try creating a simple Maven project. Okay, because it comes with Maven plugin, it is pretty straightforward. Click on Maven project, and here leave it as the default workspace location, and click on next. And I want to use Maven archetype quick start, which is nothing but a wizard for simple Java application. And then click on next. Here we have to give the group ID and artifact ID. Group ID is org, artifact ID is ITversity, and package name I want to give it as demo MR. Okay, otherwise I will leave it as default. And then if I want to add the names, I can add it all over here, or I can modify it later. Okay, as of now I will not add anything. I will just click on finish, and you can see that it has created the project with the name of artifact ID. Okay, if you want to change it, you can go to the pom.xml. Even while creating, if you give the artifact ID as something else, it will create with that name. But if your artifact ID and name has to be different, you can open the pom.xml, and you can go here and you can change it. I want to change it to demo MR, and here also I want to change it to demo MR by going to refactor rename. Click on OK, demo MR, and click on OK. Okay, so now the project name is changed, and even in the pom.xml, The name should be changed to demo MR, and you can actually get the source code of pom.xml in XML format by clicking on this one. This will give the source. This is just a graphical interface for the same pom.xml. Either you can modify some of the parameters here using better interface, or if you are familiar with XML, you can do it here. If you want to increase the font, you have to go to preferences. In this case, I want to increase because it might not be visible to you. So go to general. Here you have to choose editors, text editors. Click on colors and fonts, text font, edit, and I want to use 16 as the font size. Okay, apply. Okay, now you can see it is a little bit better. When you actually create the simple application, you will find app.java here. Okay, it is the behavior of the simple wizard with Maven, which is default archetype. Okay, you can right click on this, run as Java application, and if it runs without any issues, that means our setup of STS or Eclipse with Maven plugin is successful. Now we have the IDE to develop Java MapReduce Java-based applications, and MapReduce is one of them. So to actually convert it into a MapReduce application, first of all, we need to update the pom.xml with appropriate dependencies. Again, for that, you can go to my blog, and then you can click on the MapReduce program. And you can see all the steps which I have explained as part of this, and also the videos for your reference, which are broken into pieces. Here you have to add these dependencies which are related to Hadoop. Okay, Hadoop common, Hadoop MapReduce client core, Hadoop MapReduce client common, Hadoop yarn common, etc. And here the version is crucial. This version should match whatever version of Hadoop you have on the virtual machine or the remote host, if you want to run this on the remote server later. But to test in Eclipse, you don't need to worry much about it. But if you want to run this on a remote cluster, you need to make sure the versions are same between the pom.xml and the remote host. The way you can validate is you can log into the virtual machine. If it is up and running, it is not up and running, it will take a while to get up and running, and then we will see how to get the information about the binaries we have. And before getting into that, let us understand the version definition. So it is divided into three parts. The first one is major version, second one is minor version, and third one is revision. So if there are differences in revisions between the remote cluster and our pom.xml, you don't need to worry much about it. It will typically work without much issues, unless you are working on you hit a bug on the earlier versions. With minor version, there will be minor changes, but when it comes to the major version, you should never compile your programs if there is a mismatch between the major versions. Minor versions, one or two back and forth is fine. Revisions are within minor version, any revision might work most of the times. But with major versions and also with minor versions, if there is a conflict beyond two versions back and forth, then you have to be extremely careful. You have to test it thoroughly before after pushing it onto the remote host if there is a mismatch. That being said, now the server is up and running. So I'm trying to connect to the VM, treat the VM as a remote host. So the VM will come with the IP address. Let's use that IP address, which is 192.168.145.249. It will prompt for the password. I have to give the password here. And here I can say name, Hadoop, common. So whatever dependencies we are defining here, you have to pick the words from here. So in this case, the first one is Hadoop common, and I am trying to search with that words. So the find command is to search for the files. So here it is find slash is the root file system in Linux, -name, and then Hadoop common.jar star to replace anything in the middle. So if you see here, I am using HDP cluster, and this version is HDP version. And to get the Hadoop version, you have to look at here. So if you look into this pom.xml file, okay, so this is the group ID. You don't need to worry much about it, but the concatenation of artifact ID and version ID are the important one. If you concatenate, if you concatenate artifact ID and version, that is the jar file which we typically use. But as we are using Hortonworks, they also append the HTTP version to it. But as long as these two matches, we are good to go. We don't need to worry about this Hortonworks based versioning. The same thing applies for the Cloudera also. You just need to focus on this part after the artifact ID. So here our binaries between the remote host and the pom.xml are matching. This is the first thing you need to do. So here I am copying this content only if the dependencies related to Hadoop. I am not copying everything. Okay, if you copy everything, if there is a mismatch between the names, then the project will be in issues. So it's a very bad habit to copy everything. You just copy the dependencies you require. Don't copy this stuff. Here, if you see, the artifact ID is MR and group ID is org.idiversity, whereas here it's a different story. Okay, so it's not a good idea to copy everything. Just copy the dependencies. Once that is done, now in the org.idiversity, I want to create a new Java class. Okay, and the class name is word count, and hit enter. Okay, here I have the word count code. Again, there is a mismatch in the package names. So apart from package, I'm copying everything. Now I have the code base to actually execute the word count. Here I'm not getting into details. Sorry, the screen share is stopped. Let me share my screen in a moment, and then we will start again. Yeah, it restarted automatically. So here we can see the code snippet copied. Don't worry if you don't understand the code. If you want to understand the Java MapReduce APIs, if you go to the next topic, you will understand. I will come back to it in a moment. So now we have the word count program. We have to run this. So to run this, if you go to the program and if you start from the main function, we are passing array of strings. Okay, and those array of strings are being passed to this method. And here we are actually using two arguments. The first one is nothing but the input path, and the second one is nothing but the output path. So we have to pass the input path and output path. Input path should have the data, and output path should be a non-existing directory. So this program will try to read the data from the input path and write the output to the output path. And the functionality of this program is to get the word count. So let me generate some test data and demonstrate how we can actually run. We will be running locally. So here I have research, R&D, or this one, big data, so it is under live demos data word count.txt. So this is the location which have the word count.txt file, and this is a very small file. It's not a big data really. To just test the word count functionality, I am just using this file Here what it will do is it will take each of the word and it will try to get the count of each of the word. Okay, and so this is our input path, and we have to pass as argument. If you are new to Eclipse, if you are already familiar with Eclipse, it will be you might already know. If you are completely new to Eclipse, what you have to do is you have to right click on this program or go to run as or run configurations, and here you have to pass the arguments. Ideally it should ideally it should show here. Yeah, so it is actually minimized. So if you scroll a little bit down, you see run as option. Go to run configurations. Here, make sure you are in the right project and the right main class. In this case, main class is not correct. Main class is word count. Go to arguments. Here we have to pass the program arguments, which is this one, word count.txt, and the output path is word count output 02. Okay, we need to make sure that there is nothing in that path. So here I have given users D Gajaraju research big data live demos and then the directory name. So live demo directory is this one. Here there is no word count output 02. If you give the already existing one, it will fail. You have to give the non-existing directory. It will create the directory and it will create, and then it will copy the word count data to it. And then click on apply. It's better to change the name also because we are trying to run the word count program. So click on apply and then click on run. Now it is running. It will take a moment. It is already done. Now we can see word count output 02 is created. The path is incorrect. I give it as OUPUT, not output. And here you can see the file. And if you open that file, you can see for each word which is separated by space, it is giving the count. So the word A is repeated 10 times. Similarly, the word TH is repeated, I think, 16 times or something like that. Okay, so D is repeated 14 times. So it gives the count of each of the word in that input text. And this is how you can actually use the Eclipse IDE to develop the program. Once it is done, you can actually create a jar file out of it. For that, you just have to right click on this, go to Maven, and then, sorry, not Maven, go to run as, and then you can say Maven install. It will create a jar file. It will download all the dependencies and it will create a jar file which can be shipped to the remote host and which can be run on the remote host. I will not be demonstrating that at this time, but you can take care of it. But this is how you can build it. You just right click on it, go to run as. Now it is not showing up. The build is success. Where is that? One minute. Yeah, you have to select the project and then right click, and then you will see run as. You will see all the Maven options. Okay, you have to click on Maven install and it will create a jar file, and the jar file location is under the target directory under our working directory. Okay, so our working directory is under live demos. We have big data MR, and here we have demo MR, not this one, which is the one. Let me see, demo MR, src, and Java. This is not the one. So let me go back here where let me find name word count.java. Okay, it is under where is this path? Let me see here. Properties, live demos, big data MR. Research live demo. Okay, it's under here. This is the path. Live demos, big data MR, demo MR. Here it has created the target directory just now. Okay, and under that you can see the IT Varsity 001 snapshot.jar, which is which have the class files for our word count program and the app program. I can say jar tvf and then give the jar file name, and we can see word count related classes and also app.class. And now we can ship it to the remote cluster, and you can pass input path and output path from HDFS, and you can apply this word count program over there. This is primarily to test that we have the Eclipse IDE to develop the MapReduce programs, and we have successfully done that. That being said, now we will actually look into the Spark applications using Scala. Okay, so for that also, there are several things you need to do. You have to set up something called SBT. You have to then install Scala IDE for Eclipse, and then you have to build applications using both SBT and Scala for IDE. Okay, the way you can install SBT is you can go to here again. If you want to have the details, you can go back to the blog, and you can see the steps that are involved to install Scala and SBT. Installation of Scala is not mandatory because Scala IDE itself comes with Scala. Hence, Scala installation of Scala need not be mandatory. Okay, Scala IDE for Eclipse, and then Spark applications using Scala IDE. Sorry, you have to have Scala and SBTs, and then you have to have Scala IDE. But having Spark on your PC need not be mandatory. Okay, you just have to use Scala IDE, and then you have to use plugin which will download the Spark so that you can use the IDE itself to develop the applications. So to set up Scala and SBT, it's very straightforward. Again, you have to download the binaries for Scala, and you can untar it and unzip it in the same way as we have done with Eclipse. And you will see Scala directory here. But when you download these softwares, it's better to create the soft links after untarring it, so that if there is a new version comes up, you just have to unlink the existing soft link and relink to the newer version. That way you don't need to modify the references to your commands related to a particular software. It is a best practice with any software, not just Scala or Spring or anything. Okay, so now we can actually, once you download and install Scala and create the soft link, you have to update the .profile file or .bash profile file. Or if you are using Windows, you have to set up a couple of environment variables. So the environment variables are Scala_home. You have to set up an environment variable called Scala_home. If you don't have that, then your SBT will not work and your Scala IDE might not work. So you have to create an environment variable with this name, and also you have to append the bin directory of the Scala home to the path. Only then you will be able to run Scala commands from anywhere. If you don't do that, you will not be able to run from anywhere. You have to give the fully qualified path. So once you create this environment variable and also add bin of Scala to the path, you have to append to the path. You should not override the path. Now you can run the Scala command from anywhere, and you can actually start developing the applications. And then once you set up the Scala, you have to install SBT. So for SBT, there are installers, unlike Scala, where you have to download the tarball and untar and unzip it. SBT comes with installers. With Mac, you use Mac ports, and you can use command called port install SBT, and it will install SBT. If it is Windows, you can search for install SBT, and here you can go. On Windows, it's very straightforward. You just have to download MSI installer, double click it, it will install, and it will also update your environment variables. You don't need to worry about setting up the environment variables. For Mac, you have to use port install or view install, and where it will install SBT and it will set up the environment variables for you. Once that is done, you can validate that SBT exists by running SBT version command. You can see the version is 0.13. Okay, and now the SBT is ready. Once the SBT and Scala is ready, you can create the Scala based programs and build the jar files using SBT. SBT is similar to Maven. So Maven is for Java to build the jar files. SBT is for Scala to build the jar files. For Scala, you can also use Maven, but SBT is more preferred tool than Maven when it comes to Scala based applications. Okay. So that being said, once you have Scala and SBT, you need to add one more plugin in SBT called SBT Eclipse. The way you do it is you have to go to this location, which is under home directory. There will be a hidden directory which will be created when you install SBT called .sbt under home directory, and here you have to create a directory called plugins by running mkdir command. I have already done that. That's why this plugins directory is there. And then in the plugins.sbt, you have to add this one. Okay, add SBT plugin, com.typesafe.sbt eclipse, SBT Eclipse plugin 4.00, which means that we are actually setting up SBT to work with Eclipse. Okay, once you have SBT, again I'm going to my live demos directory. Here you can create a working space directory. So let me create a working directory. Let me name it as Scala demo 02. Sorry, MV Scala demo 02. Okay, now I can go to this location. I can create the directory structure, the base directory structure, the way I want. It has to start with src for the source files. So I'm creating a directory mkdir-p src main Scala and hit enter. And then I have to create something called build.sbt, where I have to give the name equal to Scala demo 02 version of my application. So this is the first version, so 1.0, and then Scala version. In this case, I have the Scala version of 2.11.8. When you download it, you can see that, and that is what you have to add it here. And once those 3 lines are added, you can say SBT package. And it will take some time when you run for the first time to download all the dependencies, and it will actually create a Eclipse-based layout. Okay, so I have created only 2 files. One is, sorry, 2 things. One is the directory structure src main Scala and the build.sbt. But now if I run ls-altr, you can see a new directory called project, a new directory called target, and also it should have created the .class path. Okay, after doing SBT package, what I have to do is I have to run SBT Eclipse, SBT space Eclipse. Only after plugin you can run this command. Once you run this command, it will create the necessary project-based files under this location. So first I have created only 2 files. When I run SBT package, it has created the project directory and target directory. Now, after running SBT Eclipse, if I run ls-ltr again, it actually create a hidden directory called .settings, a hidden file called .project, a hidden file called .class path. So these 3 are required to actually have the project in Eclipse. Once you have done that, you can go to the help, go to the Eclipse marketplace and search for Scala IDE. Scala IDE. Okay, you have to set it up so that you can actually start developing the Scala based Spark applications on your laptop itself. So here you can see it is already installed, so I'm not installing now, but for the first time it will say install. You have to click on that button. It will take some time and then you have to restart. And then once it is restarted, go to window, go to perspective, open perspective, other, and click on Scala and click on OK. Okay, now it will open a Scala perspective. Once it is in Scala perspective, if you go here, you can see a new Scala project, etc. Everything related to Scala. Earlier, it is everything related to Java. Now it is everything related to Scala. So I want to change my workspace here, where I want to develop my Scala-based applications. The workspace is Big Data Spark Scala. I am choosing that one. Okay, now my Eclipse is restarting to point to the new workspace because I already have the directory Big Data Spark Scala, and there we will try to develop a simple Scala-based Spark application. Okay, and here you can see the application is already there. There is a project already under that location which is called as Simple Spark. Okay, to run this one, we have to add plugin related to Spark in here. Okay, so let me actually go to import this project Scala demo 02, and then we will see how we can make it a Spark based project. Okay, so now what I'm trying to do is I'm actually importing the project which is just created now by saying file import. Let me show you again. File import existing projects into workspace. Click on next. Here, browse to select the root directory, and the application name is, it's not Simple Spark. I think the path is a little bit different here. It's under live demos. So I can go to that live demos also and choose the Scala demo 02. It is not required that it has to be in the same workspace. You can open up the projects which are in different workspaces also, but it's not a good practice. But for demonstration purposes, I am using that. But if you follow my actual content on my blog, you will see you don't see these mismatches. It will be consistent with good practices. So now I have opened the new project Scala demo 02, and there is nothing here. It's an empty project. To make it Spark based project in build.sbt, we have to add a new line. Okay, and that line is nothing but Big Data Spark Scala. Actually, I can refer from here also. I already have it here. Spark applications using Scala IDE. Here, this is the one. Library dependencies. Here you can see that we are trying to this is Maven and SBT are related. So if you think about Maven, we have group ID, artifact ID, and version. When it comes to SBT and the dependencies, this is nothing but a group ID. This is nothing but artifact ID, and this is nothing but the version. Okay, and as part of the artifact ID, it also have the version of Scala against which this artifact is compiled or this package is compiled. Again, in this case, the versions which we are defining here should match with the versions we have on the cluster. Otherwise, you might run into some inconsistencies. If there are any unexpected errors, you need to first make sure that it is not due to the version mismatch. So in this case, we don't bother much about it. We will just create the library dependencies because we are just trying to develop a simple application, and it will work without any issues. You can save it. Once you save it, again you have to go to that directory, cd scala demo-02. And now if you see here, there's only two packages, Scala library container and JRE system library. There's nothing else. Now, if I say SBT package in this location after adding the Spark-based dependencies, it will download all the binaries related to Spark. Again, if you're doing for the first time, it will take quite a bit of time. In this case, I have already done that several times in the past, so it will be faster. Now, once that is successfully done, if I right click on it and click on run as, sorry, not run as, refresh. What happened? PWD. Let me see. Yeah, let me do SBT clean. And then SBT package. There should be additional binaries, but it is not showing up here, but we will see. We will see after creating a simple Scala object, simple app. And here again, we will be copying the code. So there is some issue with the setup. Somewhere I messed it up. But if you follow my blog, it will work fine. There won't be any issues. I think first I should do SBT Eclipse, then I should have done the SBT package. Let me do that. Okay, rm-rf mkdir src main Scala mkdir-p src main Scala, and then build.sbt name Scala demo-02 version 1.0 Scala version 2.11.8. Save it. Then SBT Eclipse. Then let me run SBT package. Here I will be closing this project and then deleting this one. Okay, now I will be opening again. I will be importing the project. import, next, browse, open, finish. Okay, now let me add the dependency to build.sbt. Save it, and then sbt package. It is not working. Actually, we should see all these things. You can see it here, referenced libraries. Okay, I know why it is not showing up. It should show up. I don't know why it is not showing up here. Anyway, probably I might have I might have done some mistake somewhere. But this is the project which is working. Okay, and you can see it here under the default package. There is an application called simpleapp.scala, which is using the Spark based APIs, and we can run it here. Here it is also taking two parameters, which will tell the deployment mode, and the second one is output path, because here we are not actually reading the input path. We are creating a list in Scala. This is all Scala based syntax. Don't worry if you don't understand the Scala based syntax. You just copy the code from my website. Okay, you can copy paste here, and then again you have to go to run as, go to run configurations, and then you have to pass the arguments. So for the deployment mode, you can use local, and here we can pass the output path. In this case, this is the output path which you have given, and we can run the application. It is already ran earlier, so I'm going to that path directly and showing you the file which is created. So this is the file which is created, and you can see the 5 elements from the list is printed or copied to that file. Okay, and then once that is done, once you create the file, once it is tested with new Scala-based dependencies, Spark-based dependencies, you can go to that path and you can look into the simple Spark. And if I run sbt package, it will create the .jar file the same way the Maven has created earlier. It will create the .jar file under target ls-ltr Scala 2.11 simple Spark 2.11-1.0.jar file. So this one will have the required classes to execute it as a Spark application wherever you want to run. You can now copy this to the cluster using SCP. I have already done to this machine. Okay. So this is the application simple Spark 2.11-1.jar. Here we can run the Spark submit command like this. So the Spark submit command -- class, the class name which is nothing but simple app -- master. In this case, I'm trying to run as yarn, and then the application name. So this one is not the right one. Simple -spark. Okay, I lost in the history, but I can actually copy paste from my blog again. So this is the Yeah, this is how you can actually run. Okay, ideally it should have hyphen at the end. Sorry, slash at the end, which is the line break, and then I can run this program. Okay, first let me delete Hadoop fs -rm -r user root simple app output. Already the directory is there, so it will fail. I can copy that script now and run it. And then it will actually create the directory, and it will actually copy the 5 elements into a file in directory in HDFS. So this is how you can actually set up the environment. Now we are able to develop the both MapReduce based applications as well as the Scala based applications using Eclipse as IDE. And we have also demonstrated how to run this on the remote clusters also. So with respect to MapReduce, from here, if you want to explore, you can actually follow this blog and get the GitHub package, and also you can go through these videos to learn MapReduce in detail. This actually link to a hello friends, this is Durga again, and this is a link to a playlist. You can see it here. If you have the sandwich icon here, it is nothing but a playlist. You can expand this one, and you can see all the videos related to MapReduce APS. So if you want to learn MapReduce APS in detail, you can follow this. If you want to learn Scala in detail, hold on for a few days, and the material will be ready under Apache Spark with Scala, where we have seen these 3 items to set up the IDE for developing the Spark-based applications. And then a few more topics will coming into the same lesson as part of the near future. So there will be full content related to Scala also, and most of the content will be developed using STS itself, or Eclipse with Scala IDE for Eclipse itself. So that being said, I have demonstrated how to set up the environment within an hour. Now I can take few questions. I'm not sure whether I will be able to take the questions, but you can try asking the questions. Earlier, I have, as part of the Q&A Google Hangout on Air, people were able to ask the questions, but in this case, I'm not sure whether you guys will be able to ask the questions. However, you can give a try as part of the comment section. I don't think you can ask the questions. Probably I might have to explore how to enable the Q&A for these ones. Let me see my channel. No, it is not letting. Anyway, we will see those things. So as of now, the content is already in the blogs, so you can follow those things and make sure you set up the environment. Okay, that being said, that's it for today. This is primarily to demonstrate YouTube Live, because Google Hangouts on Air is being stopped by YouTube, and they're asking to, or Google, and they're asking me to use Google Hangouts on Air. So I thought of creating an interesting topic to validate, to understand what are the limitations and all. So if you feel any issues with this, please post the comment section. This video will be available very soon as part of my channel. You can come here and then you can ask the questions, or you can place the comments. Based on your feedback, I will take the necessary action. That being said, have a nice one. Thank you. Bye.